Hey makers. Alright, so I've got a little dilemma. I'm working on my deck and I had some staining done, and one of the little rods that has these plastic holders got broken. Let me show you. So there's supposed to be these little plastic holders that hold this rod on place, and they don't. So in order to replace it, I'd have to take this whole railing, at least loose, so that I could put some new little fasteners on this to hold it in place. So I'm going to design something. I'm going to 3D print it, and let's see how it all turns out. All right, makers, stay tuned. Hey makers. All right, so now we're to the design phase. I'm going to tilt the camera down just a little bit so you can see what we're working with. Now what I have here is I've got the rod that came from the deck railing, and you can see the piece of plastic inside and how that broke off. If you look a little closer, you'll see it's threaded, and I think those threads are not to screw it on because the inside of the rod is smooth. They're just flanged to help add some resistance so they don't just pull out. So I'm not going to so much worry about that because I'm going to kind of design this piece so that it has kind of a tight fit, maybe have to tap it in to place with a rubber mallet, and then have something on the end where we are on the side so we can go in with some small little tack screws. So what I need to do to get started is I'm going to need to take some measurements. Now you can, if it didn't have this piece of plastic, I could use this side to measure the inside of my hole, and we'll do that right now. And fitting tightly, that's coming in at 16.3. 16.3, and again I'm using millimeters. So now if I measure the piece of plastic that came out of it, I'm going to go back and put my calipers back down to 0, and then I'm going to calibrate those to 0, and I'm going to measure the inside piece of this, and that's 16 even. 16.06. I'm just going to go with 16. I think that'll be tight enough. Alright, so now that we have our design, or we know what the outside circumference of our piece needs to be, I'm going to use simply use Tinkercad, which is tinkercad.com. Sign up, make yourself an account, design away. You can edit existing STLs, you can create your own STL files, export those, they're ready for slicing and printing. So I'm going to switch over to the Tinkercad, and we're going to go ahead and design our replacement part. All right, stay tuned. All right, so here we are on Tinkercad. It's a free website, tinkercad.com. Sign up and you can start making your own designs and printing those out today. You'll see that I've got a lot of designs here. These are not all mine. Some that I have downloaded from Thingiverse, and you can import those STL files into Tinkercad and edit them to fit your needs. Typically I'll download something and I'll pull it into here to change up the design or something like that. So what we're going to do today is we're going to go ahead and create a new design. You'll see they always automatically give it this name, so I'm going to change this to deck project. Alright, so we're making a cylinder. We've already gotten our measurements. The measurements came in at 16 millimeters even, and I'm going to make that at about 16.2 just to give us a little bit of a tight fit. 16.2 and 16.2. Now again, Tinkercad is pretty simple. It's for basic things. If you need to do more advanced designs, there are programs out there that can do that. So I just took my circle and I increased the number of sides to make it more round, so there's no edges on it. And we're at 16.2. We should be 20 millimeters tall, and let's take a look at 20 millimeters here. 20 millimeters, maybe a little bit long, but I don't want to come in too short, but I'm going to come in at 15. 15 will be good. Alright, so now this is going to go inside the rod. I'm going to need to print 2 of these per rod, which is good because I only have one rod that's broken. So this is going to go right up inside the middle of the rod. Now, we got to give it a little base here, something that we can use to tack on. So I'm going to take another circle, and I'm going to make this, actually, let's just replicate this, and I can duplicate, bring it over here, and I'm going to make this just a little bit bigger. Let's see. Yeah, you know what? Let's try this. Let's make that a 5. And make that a 5. Oh, I think I got it all off centered. So let's try that again. We're going to make this, pull it off. Let's not make it 5. Let's make it 7. 7. And we'll make it about, let's say 3 millimeters thick. Let's just slide that right here. And I'm going to make another copy of that and slide that over here to the what happened there? I'm not perfect at design, but I know my way around a print, so we're just gonna go with that. Alright, so I don't want those sticking out too far. I just want to give it something that I can put a nail in. Alright, let's make sure those are all lined up. So I'm going to use the align tool and just align it by center. There we go. And I'm going to go ahead and combine this and make this all one. Alright, that's all one piece. Now I need to be able to put my nail down through there without hitting the rod, and so that I can tack it into the wood. So I'm going to grab a hollow one, and I think I'm going to make this 3. And 3 might actually be a little bit big. Let's make that a 2. 2. Alright. And I'm going to basically bring in this right in here, and I'm going to pull this at a 45-degree angle. Or should I say a negative 45-degree angle. There we go. And I want to get it so that it goes all the way through. So I'm going to go down to about a -5. See, that puts it on the bottom part of your build surface right here, so that it goes all the way through. And I'll bring that in here. And I want another one of these for the other side, so I'm going to replicate that. I think I made 2. I did. This one here we want to invert. I can either bend my angle back 180 degrees, or I can just use the flipping tool and use the flip and do that. Alright, let's use our alignment tool real quick to line those up so everything's in a line. There we go. And I'm going to bring this one in just a little bit. Now let me move my camera up here a little bit so you can see. Down here I can change to snap to grid, or how much when I move it. I'm going to change it to 0.1 millimeter. So that way you can really kind of define where this is going to go. Now remember, my pipe is coming on, or coming down over this sleeve, and it's going to rest right down here. So I don't necessarily want that resting where the nail is. So we're going to bring it out just a smidge. Alright, so I think I need to pull this one out just a little bit. So I'm going to have to break my... There we go. I'm going to move him out just a little bit, so that I can move this out just a little bit, just to give the pipe some room to seat. And I think this one here needs to come out a little bit too. Alright, so now I've got my holes, and that's where I'm going to nail in, because my pipe's going to sit right on top of this, and I'm going to tack my little tack screws in here, basically just to hold it in place. It doesn't take any stress or hold any weight, so I'm not worried about it being solid as a rock. There we go. We'll take a look down here, and you can see your hole goes all the way through, and they come down into an angle. So our screws will come, or our little nails will tack right in. This right here is going to hold our rod, and these are just solid enough too, so that they can bear the weight. Again, those are only 3 millimeters thick. 3 millimeters is not very much, but it's going to be more than enough just to hold these into place. Okay, so now that I've got this designed, I maybe don't want to use so much plastic. Again, because this is a low stress bearing area, and then that was 16.2. So let's go ahead and let's take a hollow down to 15 millimeters, and we want to make sure that this is tall enough to go all the way through. And let's make it round. Okay, that might be a little too thin on those outside walls. So let me go down to, say, 13 on both sides. And let's center this up. Now, because we're centering both of these circles, we want to center them both ways. Alright, and then I'm going to, let's see, do I want to punch that down through, or do I want to give it a base? I want to give it a base. So let me pull this up. Right now, we're sitting flat on the bed at 0, and you'll see right over there is a little dial, and we're going to want to bring this up, let's say 3 millimeters. So we'll go over there and we'll just poke in a 3. So our 3 millimeter base is going to be just as thick as these little flanges that we've got setting out to hold our screws. So it's going to have a base of 3 millimeters. It's 15 millimeters tall, and we've got an outside wall that is let's see, that was, how much did we come in? We came into 13. This right out here is a 16.2, so we got about a 3 millimeter wall, okay, give or take. And I think that's going to be more than enough. This should be a pretty nice solid little piece. It's going to be a fast print because it's so small. And again, I'm going to have to print 2 of these. So we'll go ahead and combine those and take a look at our final product. Looking good. All right, so I'm going to go over here to export. I'm going to export that as an STL, and I'll find that in my downloads, and I'll drop it into my slicer. So stay tuned. Alright, so I use Simplify 3D as my preferred slicer. You could also do this in Cura. If you're following along and you're using Cura, or that is your slicer preference, or something else that's out there, the settings are all going to be kind of the same. But again, this is really more about just the practical use of using your printer, and no idea is a stupid idea. 5 minutes into it, you can have your product or project complete and ready to print. So let's take a look. Okay, so I've already got this on my printer bed, and I want another one because I need one for both. So let's go up here to, I'm going to go to edit, and I'm going to duplicate the model. I'm going to make a couple of extra ones. So I'm going to replicate this 3 times. So that gives me 4, and I will center those on the bed. And now I've got 4 different ones. Now I'm going to keep 2 the way that I designed them. This one here, I am going to scale down. By 5%. That's going to make it just a little bit lower, smaller, and around. This one here, I am going to upscale 5%. It's going to make it just a little bit bigger, and maybe 5% bigger is too much. Yeah, let me upscale it by 2%. And this one here, let me downscale by 2%. Slightly bigger, slightly smaller. Our measurements are good, but they might just be a little bit tight. If our two original ones come out, we're done with the project. If they don't and one of the other ones fit, that gives us an idea. We can come back, print one more, project's done. All right, so let's check our printer settings. Let's see here. My extruder, all my settings are, I use all of these settings on my Ender 2, so I never make any changes here. My nozzle diameter is always a 0.4. For layers, this is where the primary of my changes will go. I do like to print it at a 0.12. Layer height, that seems to give me nice clean finish. The layer lines are not real thick. A lot of times I'll just print at a 0.2, but for this project doesn't really matter. Now looking at your solid layers here, because we are going to be printing something that's going to be outside, it's not going to have direct sunlight, and I don't really anticipate it being hot, so I don't mind going with PLA. If it was something that was going to be exposed to sunlight, I would use PETG, and I have done that on a couple of other projects to like hold some little solar panels in place for some lights on my deck, and those are exposed to the sun constantly, and the weather and the rain and the snow, and I've had them up there for just over a year now. They have not warped or broken or anything like that. They hold those little solar panels in place for my deck lights. They're great, and I used PETG. I believe that was an Inland PETG I got from Micro Center. You can also find that on Amazon. Very affordable PETG, and it prints great. So I think with here, some of my previous settings, I had 4 layers, and what that means is it's going to create 4 solid layers on top, 4 solid layers on the bottom. Those layers are 0.12 millimeters thick. So you do the math. I like to use 4 layers because when I use infill, 4 layers gives it a really nice finish, and nice clean finish. Now for your outside perimeters, for this one where it draws outside of the perimeter and is building upward, I have 4 layers on that. Now that gives you your thickness of how thick the outside diameter is. Now a lot of people like a lot of outside diameter and lower infill. Some people would raise the infill and somewhat, because then your infill squares are tighter. Your outside layers, you could go with a 3. I wouldn't go any lower than 3 unless you're doing like something in vase mode. But I usually will have my solid top layers, solid bottom layers, and my outline and perimeter shells anywhere from 4 to 6, depending on the project that I'm printing. So with this one, I'm just going to go ahead and leave as a 4. We'll click on the additional tab, and I don't need to do a skirt because this, being a solid base, it's going to have nice bed surface for good adhesion. I don't need a raft because I'm not printing any supports or anything like that. I don't need anything here. I don't need an ooze shield. For my infill, because the part and those walls are only 3 millimeters thick, and then that base is 3 millimeters tall with a 16 millimeter circumference, probably a 10 to 15. I'm going to take this to 15% infill, again just to give it a little bit of strength, because again it's not holding any, it's not load bearing or anything like that, but I do want the print to turn out well, so I'm just going to give it that to give it some stability. I don't need any support material, so I can uncheck this. Temperatures, since I'm going to be printing with PLA, my heat bed is going to be at 60, and my temperature for the filament is going to be 235. I'm using MakerGeek's Maker Series PLA. Cooling, I'm going to start cooling that probably right around layer 3, and we're going to set that cooling. I tend to like to, I start off my first layer, first couple of layers with 0 cooling. That gives the filament good adhesion to the layers and good adhesion to the bed, because your bed is at 60
degrees Celsius, so that plastic is adhering to whatever type of build surface you have, or if you're using a treated glass, it will let it really set onto that. And then you start your cooling, which is blowing fans down on and cooling the filament as it leaves the extruder. I usually start around the third layer, and I'll do a 45, and then usually by layer 10, I've taken that up to probably 75. Very rarely do I cool at a 100%, where the fan is just full on cooling that filament, unless I'm doing a lot of overhang and a lot of supports, and I want to make sure that I don't get a lot of strings. Okay, so cooling, everything else should be set. My speed, because this is a smaller piece and again is somewhat of a prototype, I could do it at 62, but it's also a pretty small piece, so I'm going to take that down to 52 millimeters per second, and I'm going to let that just calculate itself down across the rest of the settings, because they will run at percentages except for your movements, which is those are good settings for movements, especially on my Ender 2. They do not cause too much vibration, jerk, or artifacts on my prints. All the other settings are just fine where they are. So I'm going to go ahead and click OK on this. And I'm going to prepare a print. There we go. I'll make sure you see all the screen just in case you're following along. Alright, so now we were looking at that infill and how small these parts are, right? So I want to just take a look and see how that infill looks. So I'm able to use this play right here, which is a simulated play. Now if you'll see, because we went with 4 layers and the 3.5 millimeter or 3.2 millimeter thickness on the wall, we're not using any infill. It uses the outside shell, so basically we're going to be getting 100% infill without any of the honeycomb for our outside perimeter, which is fantastic. So let's bring that down just a little bit more till we get to that base and see how big our honeycombs are there. Alright, those are pretty big, and I think that's good. That's going to give us a good solid base there at the bottom as it starts to build that top layer right here. We're not going to get a lot of sagging. The Ender 2 works really well, and plus we are at layer 21 for this already. If you look over here, let me move my camera. Look over here, we're on layer 21, and by layer 21 I've already got cooling turned up to 75, so it's going to bridge across this honeycomb really well. And it's just going to continue to build up on the outside of that perimeter until it's done. And we're good to go. So I really like this design. I think it's pretty simple, and what we needed to do is actually very simple. So I'm going to go ahead and export this and save it as the deck project. I'm going to print this on my Ender 2. So I'm going to sit on here and say, call that E2 PLA. There we go. Deck project and save. Now let's see. I've got my Ender 2 up here. Should be right there. This is my CR10 printing right now using Octoprint. Got a Baby Groot going with Charlie Brown from Maker Geeks. It's a Maker Series PLA. And this is the Baby Groot that has the little flower pot or herb pot in its head. So you'll see that it's already printing the hollow part of the inside of his head. And I think this has been printing for about 8 hours. Let's see. It's been printing for 10.5 hours. It's at 66%. I'm sorry. It's been printing for 21 hours. It says there's 10 hours left, but this Octoprint's not the best with time. It knows how long it's been running, doesn't necessarily always know how long it's got left. I'd say this will probably be done in about 3 hours. Okay, so let's go over to the Ender 2. I don't have a camera set up for my Ender 2, but I will have it set up so that we can capture the printing of this object. And let's see here. Let's go back over to our slicer where we saved it, right here. And hold on, I gotta make this a little bit smaller. And open this up. We got our Ender 2 PLA deck project. We're just gonna drag and drop that over. There it is. And the Ender 2 is on. So all I gotta do is send the print, and it's gonna start ramping that temperatures up. 60 degrees Celsius on the heat bed, 235 for the nozzle, printing with Maker Series PLA from MakerGeek.
Alright, so we got the pieces off the printer. Now we need to test them out. Now remember, I did 2 by our original measurements, which was 16.2, and then we did one that was upsized 5% and one was downsized 5%. So let's see where those landed. I'm going to tilt the camera back down so you can see us testing these out. Alright, so here's our final piece. Turned out just like we designed it. And let's see how it goes in. Nice tight fit. Perfect. And it seats in there really well. There's just a little bit of a gasket effect around the piece. Still gives it access to the little holes so I can tack those down to the deck. So let's see how the other one fits. Well, we know the one that with our measurements works. So let's check the one that's upsized by 5%. This one fits definitely a little more snug, even though it's just a hair bigger. It's definitely tighter, and I could probably heat this up with the heat gun, or I could just tap it in with a mallet, but it's definitely going to be in there for good. So I think I'll set that one off to the side. And then here's the one we downsized by 5%, and that one goes in with very little resistance, and you can see it still has a little bit of wiggle and doesn't really give us the overhang here that we're looking for to be able to tack in our little nails. So this one here has just a little bit more, and the one we downsized by 5%. So here's the other one that I printed with our measurements. Fits in nicely, no wobble, and I think that's going to do just fine. Alright, well there we go. I'm going to take these out and we'll get those tacked into place, and I'll show you how it looks finished. Thanks for sticking around. Alright, so got everything in place, got it all tacked down. As you can see, everything's solid. One on the top and one on the bottom. Blends in really well. It's low profile, so you can't tell the difference between the two, but we know it's there. And that's what we do. We come up with an idea, design it, and go print it. All right, well, thanks for following this video for i3DKC. Go make something.